Hello students, welcome to the digital signal processing. We are going to discuss today the properties of Z transform. Let's discuss the second property of the Z transform, that is the time shifting property. So when we say it is the time shifting property, it means signal x of n will be delayed by either k or minus k. Here in the time shifting property, we can easily obtain the difference, that is x of n minus k will have the z transform, that is z raised to minus k x of z. So where the k is an integer value, so if positive the sequence is shifted right. So whatever the expression right now available with all of us, that is nothing but with the positive value of k. If negative the sequence is shifted left. So x of n plus k, that will be applicable for negative value of k, and this equation will become z raised to plus k x of z. And obviously the ROC can change the new term, maybe like add or remove poles at z equal to 0 or z equal to infinity. Let's discuss one example over here. Example is quite simpler. If x of z is given, let's say z raised to minus 1, 1 upon 1 minus 1 by 4 z inverse, and the ROC is given like mod z is greater than 1 by 4. So from this x of z, let's assume that we need to obtain x of n. It is like inverse z transform. So when we say x of n is to be converted into the x of z, it will be the z transform. In a reverse way, when x of z is to be converted into the x of n, it will be the inverse z transform. So for this given expression, we say this term is just highlighted over here. So this term is nothing but 1 upon 1 minus az inverse. So a over here is nothing but the value 1 by 4, and which is specified as a n minus 1, that is nothing but obviously the delayed value. So it can be just point out here as a u of n minus 1, since it is delayed by 1, that can be monitored over here z raised to minus 1. So in this way we can just obtain even the z transform or inverse z transform. So let's see what exactly the conclusion for this entire property. Here x of n minus n0 indicates that the sequence is shifted in the time domain by minus n0 samples, corresponding to multiplication by z raised to minus n0 in the frequency domain. So when we want to discuss further, the conclusions can be drawn like, here the sequence is shifted in time domain by minus k samples, corresponding to multiplication by z raised to minus k in the frequency domain. So the ROC can be easily figured out as a ROC of z raised to minus k is same as that of the x of z, except z equal to 0 if k is greater than 0 and z equal to infinity if k is less than 0. Similarly, we can go for the third property, that is scaling in z domain. It means multiplication by exponential term. So that can be easily just grabbed over here, that a raised to n x of n will have the z transform x of z by a. So ROC for this one is scaled by mod a. If a is positive real number, z plane shrinks or expands. Let's see the example for this one. Let's say this is what u of n will have the z transform, that is 1 upon 1 minus z inverse. So a raised to n, so here the value of a is, let's say 1. So 1 raised to n, it will be 1. So obviously 1 upon 1 minus z inverse, that is what the z transform for this u of n. So ROC for this one is mod z greater than 1. Ultimately it will produce some kind of expression which is desired one. Let's proceed for additional values to be added, the verification of the scaling in z domain. So for this one we will go for second example like this. let's say x of n is equal to r raised to n cos omega 0 n u of n, which can be separated out like 1 by 2 r e raised to j omega 0 n u of n plus 1 by 2 r e raised to minus j omega 0 raised to n u of n. So let's find the z transform for this one. So obviously the z transform for this one will be simplified in terms of x of z. That will be 1 by 2 will be common value over here. So that can be just figured out. So this is what 1 by 2, 1 by 2, and the rest of the z transform. Since here r e raised to j omega 0, this will be acting as a, so that is why the remaining term at the denominator will reflect 1 minus a, so that is r e raised to j omega 0 z inverse plus 1 by 2. Again, since it is a constant value, let's take it outside. So it will be here. Next value is r e raised to minus j omega 0. So that can be reflected as a. So a raised to n u of n. So it will be reflected as a 1 upon 1 minus r e raised to j omega 0 z inverse. So this is overall z transform to verify the scaling in z domain with respect to some of the examples. So let's see what exactly the ROC for this one. ROC is quite simpler. It is nothing but mod z greater than r. So that is what we have seen in earlier cases also, to determine the ROC of the given sequence. So let's see now the next properties in the next lectures. So thank you everyone. Thank you very much.